Oil and gas project step consists of conceptual study, FEED, and EPC. Conceptual study is to determine the best option of the facility development. After conceptual study, the next project step is FEED, front-end engineering design. Then, after FEED, the project will be executed in EPC, engineering, procurement, and construction. As a matter of fact, the processing facility development is a result of synergy between multidiscipline engineer. There are process engineer, electrical engineer, mechanical, instrument, civil, etc. Discussing about the total investment cost for oil and gas EPC project, we can use a simple analogy by using this mineral water bottle. If this bottle is assumed as the total investment cost for oil and gas EPC project, then the cost for engineering itself will be equal with this bottle cap. Meanwhile, for the investment cost for procurement and construction will be equal with the rest volume of this mineral water bottle. That's why the discussion about oil and gas project is always interesting. Tahapan oil and gas project meliputi conceptual study, FEED, dan EPC. Conceptual study bertujuan untuk menentukan best option dari facilities development. Kemudian sesudah conceptual study, tahapan selanjutnya adalah FEED, front-end engineering design. Sesudah FEED, project akan dieksekusi di tahap EPC, engineering, procurement, dan construction. Pada faktanya, processing facility development itu merupakan hasil dari sinergi multidisiplin engineer, yaitu proses engineer, mechanical engineer, electrical, instrument, civil, dan lain sebagainya. Membahas tentang total investment cost untuk oil and gas EPC project, ada analogi sederhana dengan menggunakan botol air mineral ini. Jika botol ini dianggap sebagai total biaya investasi untuk EPC project, maka biaya investasi untuk engineering saja adalah sebesar tutup botol ini, sedangkan biaya investasi untuk procurement dan construction adalah sebesar sisa volume dari botol air mineral ini. Itulah mengapa diskusi tentang oil and gas project selalu menarik. Tahapan proyek oil and gas terdiri dari conceptual study, FEED, dan EPC. Conceptual study atau feasibility study bertujuan menentukan best option dari facilities development tersebut. Best option adalah pilihan terbaik berdasarkan berbagai pertimbangan seperti technical reason, resiko, maupun cost. Sesudah conceptual study, tahap selanjutnya adalah FEED, front-end engineering design atau disebut basic engineering design, yang merupakan desain awal fasilitas berdasarkan best option yang telah diputuskan pada saat conceptual study. Sesudah FEED, project akan dieksekusi pada tahap EPC, yaitu engineering, procurement, dan construction. Pada tahap ini, detail engineering design dilakukan untuk procurement sistem maupun equipment dari fasilitas itu, kemudian dilanjutkan dengan construction, commissioning, dan startup fasilitas tersebut. The oil and gas project stage consists of conceptual study, FEED, and EPC. A conceptual study or feasibility study is to determine the best option for development facilities. The best option is based on various considerations such as technical reason, risk, and cost. After the conceptual study, the next stage is FEED, front-end engineering design or basic engineering design, which is the initial design of the facilities based on the best option that have been decided during the conceptual study. After FEED, the project will be executed at the EPC stage, engineering, procurement, and construction. At this stage, detailed engineering design is carried out for the procurement of required system or equipment from the facility. Then proceed with construction, commissioning, and startup of the facility. Conceptual study dalam hal ini bertujuan untuk menentukan best option dari processing facilities yang akan dibangun. Untuk cadangan minyak atau gas di offshore, maka processing facilities bisa saja di offshore karena terletak di remote area. Untuk tipe cadangan seperti ini, jika menggunakan onshore processing facilities, berakibat transfer fluid dari well facilities di offshore melalui flow line kurang menarik dari sisi teknis dan cost. Namun, cadangan minyak atau gas di offshore tersebut juga bisa menggunakan onshore processing facilities karena mempertimbangkan lokasi cadangan meskipun di offshore namun cukup dekat dengan onshore sehingga transfer fluid dari well menuju onshore facilities via flow line cukup menarik dari sisi teknis dan cost. Conceptual study in this case is to determine the best option of the processing facility to be built. For offshore oil or gas reserves, processing facilities can be offshore because they are located in a remote area or very far from onshore. For this type of reserve, if using onshore processing facilities will result in fluid transfer from well facilities in offshore via flow line, which is less attractive from a technical and cost perspective. However, offshore oil or gas reserve can also use onshore processing facilities because they consider the location of the reserve even though they are offshore but close enough to onshore so that the transfer of fluid from well to onshore facilities via flow line is quite attractive from a technical and cost side. Conceptual study pada slide ini adalah untuk pemilihan offshore gas processing facilities. Terlihat pada slide ini bahwa pemilihan processing facilities perlu mempertimbangkan fluid properties dari gas well production, terutama kandungan impurities. Hal itu karena processing facilities didesain untuk memproses fluid dari well sehingga mencapai spesifikasi produk yang akan dihasilkan. Pada slide ini, sistem gas treatment meliputi gas dehydration unit, mercury removal, dan lain sebagainya untuk menghasilkan produk yang memenuhi spesifikasi sebagai sales gas. The conceptual study on this slide is for the selection of offshore gas processing facilities. It can be seen on this slide that the selection of processing facilities needs to consider the fluid properties of gas well production, especially for the content of impurities. This is because the processing facilities are designed to process fluid from the well so that it reaches the product specification to be produced. It can be seen in this slide also that the system for gas treatment consists of gas dehydration unit, mercury removal, etc. to produce product that meet specification as sales gas. Conceptual study perlu mempertimbangkan technical issues yang meliputi penggunaan proven teknologi, fabrication maupun konversi fasilitas tersebut, isu-isu terkait transport, ventilation, hookup, decommissioning processing facilities tersebut, hal-hal terkait recovery, well intervention, flexibility, robustness dari sistem yang ada, uptime, reliability processing facilities itu. Conceptual studies need to consider technical issues include use of proven technology, fabrication and conversion of the facility, issues related to the transport, installation, hookup, decommissioning, processing facility, matters related to recovery, well intervention, flexibility, robustness of the existing system, uptime, reliability, processing facilities. Potensi resiko-resiko yang perlu dipertimbangkan pada conceptual study meliputi kesehatan yang bisa berupa noise, space untuk mastering, dan lain sebagainya. Keselamatan bisa meliputi bahaya gas bertekanan tinggi, potential injury atau damage. Lingkungan dapat berupa leakage atau kebocoran maupun polusi. Isu kebakaran dan ledakan adalah potensi kebakaran maupun ledakan akibat proses maupun non-proses. Kemudian kerugian aset meliputi loss of facility, structural event, maupun loss of production. Potential risks to be considered during a conceptual study include health, can be noise, space for mastering, etc. Safety can be high pressure gas hazard, potential injury or damage. Environment can be leaks or pollution. Fire and explosion can be potential fire and explosion due to process and non-process. And asset loss can be loss of facilities, structural event, or loss of production. Tahap akhir dari conceptual study adalah penentuan best option berdasarkan pertimbangan technical issues, cost methodology yang meliputi CAPEX, JLEC maupun OPEC untuk evaluasi ekonomi, serta qualitative risk assessment. Kemudian berdasarkan best development option akan dibuat environmental permit atau AMDAL. The final stage of the conceptual study is the determination of the best option based on technical issues. Cost methodology consists of CAPEX, JLEC, OPEC for economic evaluation, and qualitative risk assessment. Then based on the best development option, an environmental permit will be developed for the facility. FEED dilakukan setelah selesai conceptual study. Pada tahap ini, sebelum dimulainya EPC, berbagai studi dilakukan untuk mengetahui masalah teknis dan memperkirakan biaya investasi. Pada tahap FEED, studi perhitungan peralatan maupun desain processing facilities yang meliputi pembuatan gambar-gambar teknis yang melibatkan multidisiplin engineer dilakukan untuk perhitungan biaya investasi yang optimum dari fasilitas itu. FEED is carried out after completing of the conceptual study. At this stage, prior to the commencement of the EPC, various studies are conducted to identify technical issues and estimate investment costs. In the FEED stage, study equipment calculation and also processing facility design that consists of development of technical drawings involving multidiscipline engineer are carried out to calculate the optimum investment cost of the facility. Tahap EPC meliputi engineering yang merupakan detail engineering berdasarkan hasil studi dan desain pada tahap FEED. Kemudian procurement yang meliputi international procurement untuk semua konstruksi maupun material mechanical, electrical, plumbing secara umum. International procurement untuk peralatan proses maupun internasional logistik peralatan proses dari seluruh dunia. Ini berlaku untuk kontrak EPC skala besar. Kemudian dilakukan construction untuk semua pekerjaan konstruksi proyek EPC, yaitu tiang pancang, beton, struktur baja, perpipaan, pemasangan peralatan, pengecatan, isolasi, instrumentasi, kelistrikan, utilitas, pekerjaan tanah, pekerjaan mechanical, electrical, plumbing, maupun pekerjaan erection pada umumnya. Dan dilanjutkan dengan pre-commissioning, commissioning, dan startup service dari fasilitas tersebut. EPC consists of engineering that will be detailed engineering based on the result of the study and design during FEED. Then procurement, there will be international procurement for all construction and general mechanical, electrical, plumbing materials, international procurement of process equipment, international logistic process equipment from around the world. This one is for large-scale EPC contracts. Then construction. All EPC project construction work, for example, piling, concrete, structural steel, piping, equipment erection, painting, insulation, instrumentation, electrical utilities, earthwork, mechanical, electrical, plumbing works, general erection works, etc. After that, pre-commissioning, commissioning, and startup service for the facility. Berikut ini adalah diagram alir aktivitas proses engineer selama FEED dan detail engineering design. Pertama adalah pembuatan proses desain basis yang menjadi dasar bagi desain fasilitas yang akan dibangun. Kemudian dilakukan simulasi fasilitas proses maupun utilities itu dengan menggunakan HYSYS atau Unisim untuk mendapatkan physical properties yang diperlukan untuk desain dan perhitungan berbagai peralatan. Sesudah itu baru dilakukan pengembangan untuk drawing maupun dokumen yang meliputi proses flow diagram, heat and material balance, filosofi, proses study, dan proses calculation. Tujuan utama serangkaian kegiatan proses engineer ini adalah untuk pembuatan PNID yang nantinya akan menjadi dasar bagi engineer disiplin lain untuk melakukan study dan perhitungan sesuai bidangnya. The following is a process engineer activity flowchart during FEED and DED. First is developing of a process design basis, which is the basis for the design of the facilities. Then perform a simulation of the process and utilities facilities by using HYSYS or Unisim to obtain the physical properties for design and calculation of various equipment. After that, the development for drawing and document is carried out. For example, process flow diagram, heat and material balance, philosophy, process study, and process calculation. The main objective of this series of process engineering activities is to create PNID, which will become the basis for other discipline engineers to carry out studies and calculation according to their fields. Dokumen dan drawing yang menjadi tanggung jawab proses engineer adalah seperti terlihat pada slide ini. Dapat dicermati bahwa selama conceptual study hanya akan dibuat PFD, namun selama FIT dan DED akan dilakukan pengembangan PNID. Untuk studi dan perhitungan selama FIT dan DED juga lebih banyak dan komprehensif. Berdasarkan PNID dan desain dari disiplin lain, kemudian dilakukan estimasi terhadap biaya investasi dari fasilitas yang akan dibangun. Responsibility of the process engineer are shown in this slide. It can be seen that during the conceptual study only PFD will be developed, but during FIT and DED there will be PNID development. The studies and calculation during FIT and DED are also more extensive and comprehensive. Based on PNID and design from other disciplines, then an estimation of the investment cost of the facilities to be built will be calculated. Slide ini adalah contoh gambar beberapa equipment system pada masa konstruksi untuk onshore processing facility. Di sini terlihat gas filter, water polishing vessel, dan production separator. Sinergi dari multidisiplin engineer tentunya sangat diperlukan untuk bisa membangun sistem ini yang melibatkan proses, mechanical, electrical, instrumen, civil, dan lain sebagainya. This slide is an example image of several equipment system during construction for the onshore processing facility. Here you can see gas filter, water polishing vessel, and production separator. Synergy of multidiscipline engineer is very necessary to be able to build this system that are process, mechanical, electrical, civil, instrument, etc. Slide ini adalah contoh gambar flare knockout drum system selama masa konstruksi untuk onshore processing facility. Di sini terlihat adanya flare knockout drum, kondensat pump, instrumen electrical, dan piping terkait. Sinergi multidisiplin engineer tentunya sangat diperlukan untuk bisa membangun sistem ini yang meliputi proses, mechanical, electrical, instrumen, civil, dan lain sebagainya. This slide is an example image of a flare knockout drum system during construction for the onshore processing facility. Here we can see the knockout drum flares, condensate pump, associated instrument, electrical, and piping. Of course, a synergy of multidiscipline engineers are required to be able to build this system. There are process, mechanical, electrical, civil, instrument, etc. Nah, kalau slide ini adalah contoh gambar fan stack beserta piping terkait dalam masa konstruksi untuk onshore processing facility. Sudah pasti untuk bisa sampai tahap konstruksi fan stack system ini tentunya kerjasama multidisiplin engineer sangat diperlukan yang meliputi proses, mechanical, civil, dan lain sebagainya. So, this slide is an example of fan stack image and the associated piping during the construction period for the onshore processing facility. It is certain that to get to the construction stage of fan stack system like this, multidiscipline engineering cooperation is required. There are process, mechanical, civil, etc.
Jangan lupa subscribe, like, dan share video ini ya. Terima kasih sebelumnya. Please don't forget to subscribe, like, and share this video. Thank you in advance.